Imagine you are sitting on a gold mine of 7 million product data records. Now, what if you want to perform a real-time sentiment analysis as well as indexing on this data? Sounds challenging, right? Well, one of the ways you can do this is to have them streamed over on a TCP/IP socket connection with a technology like Apache Spark, performing sentiment analysis with a large language model like ChatGPT, streaming them to Kafka, as well as indexing them on Elasticsearch. That's precisely the solution we are crafting in this video today. So come along and let's dive deep into this exciting journey. Why don't we get started by creating a new project? I'm going to call the name of the project Realtime Streaming. I'm going to be using Python 3.9 as my base interpreter, and I'm going to click on create. Now that the project is created, I'm going to go into the terminal and initialize it. I'll minimize this, and then we create our folders that we'll be using for the project. So I'm going to be making a directory. I'll call the directory SRC. And that's where we're going to be putting all the data that we're going to be using in the project, including the jobs that we're going to be writing with our Spark streams, as well as the socket connection that we're going to be creating, and even our Docker Compose that we're going to be using in the project. So let's continue. So in our SRC, I'm going to change my directory into SRC. And from there, I'm going to touch our Docker Compose to start with the architecture. We have our Docker Compose, and I'm going to need a Docker file. I'm going to have dockerfile.spark. And inside this SRC folder, if you have been following this channel for some time, you will realize that we have the same architecture set up before. I'm going to be using this master worker architecture in this instance, but I'm not going to be using the multiple workers. I'm going to just be using a single worker. I'm going to have one master and one worker on the system that are going to be working together to facilitate the streaming as well as the job submission. So let's continue. In our Docker Compose, I'll just copy paste that. And again, if this is your first time, to just quickly recap what we have in the Docker Compose, we're going to be building a new image from our Docker file, which is the dockerfile.spark. So in the Spark master, we're going to have a Spark master that has, I'm going to just increase this a little bit. Yeah. So our our Spark master is going to have the container name of Spark master, the host name of Spark master, and it's going to be building the image from a Docker file. This is the command to start the master, and these are the volumes that are attached to it. So we're going to be creating these folders as well as this requirement.txt to get the application started. I'm going to be exposing ports 9090 and 7077 so we can track our jobs and submit our job. Then this is the network that we're going to be working with. Then for the Spark worker, we're going to have the Spark worker container name and the host name, also building for this from the same image, but the command is going to be different. The command is going to be a worker command, and it's going to be communicating with the master on 7077. The same volume applies to the worker too, and then we have is depending on the master, and these are the environment variable. Again, if you reduce this, your Spark worker may not work well. So I think the minimum is 1 gig. You can experiment to something like 500 MB or thereabouts. But I think when the last time I tried, it wasn't working. So yeah, if you now want to add multiple workers, you can add them through Spark Worker 2 or something like this. You just need to uncomment this part. But I'm going to save my compute power and just limit it to Spark Worker and a master. Once that is done, we go into our Spark dockerfile.spark, and I'm going to copy paste into that too. And this is going to be the image. This is the step. We have the image in here, the Spark latest, and we're going to be copying the requirements.txt, which we don't have right now. We're going to be having our user root. We'll switch to the root user so we can install all of these dependencies on the image. And once that is done, we build the image and we run. So, all right. So once these are done, the next thing we want to do is have these mappings that we have. So I'm going to be making a directory of config, I'm going to be having our jobs and the data sets that I'm going to be using. Okay, now once I make this directory, you can see them in here. I'm going to be installing the packages into the requirements.txt. So I'm going to be installing the packages. The package that I'm going to start with, I'm going to be using, like I said, we're going to be installing OpenAI. Okay, we don't need Faker. We're going to be installing OpenAI, Apache Spark, Confluent Kafka, and Kafka Fast Avro. The OpenAI is going to help us to connect to the large language model on OpenAI, so we can use the sentiment for the sentiment analysis that we're going to be working with. And the PySpark that we're going to be installing is to have Spark streams on our system, of course, so we can stream data from the socket and also to Kafka. The Confluent Kafka is the package that I want to be using for this project. You can use something like Kafka Python or the rest, but I'm going to be using the Confluent Kafka anyways. The fast Avro is for the serialization and deserialization of the key value pair that we're going to be sending to Kafka. So, well, once that is done, it's going to be going on in the background, and I'm going to just generate the pip freeze. Once that is done, into our requirement.txt, I'm going to do pip freeze requirement.txt, and all the dependencies and the packages that we just installed will be pushed into the requirement.txt, and you can see them in here. Now we're getting there. The next thing we want to do is get our config. Okay, then we can now start creating our jobs, data sets, and the requirements. I think we might even go ahead with the data set first. So if you want to get the data set for use again, you can download the data set from yelp.com, and this is the website that provides the data set we're going to be using. It's an open data set that is for learning purposes, so you can use this data set for anything you want, right? And we're going to be focusing on the reviews part, which is about 6.9 million reviews. We're going to be using that to stream data into the system. We're going to ignore the businesses, pictures, and the metropolitan area. So if you want to download the dataset, you click on download dataset, and then you fill in your details. They're not going to be sending you any email. This is just to keep track maybe of the people that are downloading the package or the dataset. Okay, and once that is done, it's going to download a zip file into your system. I've already done that, so I'm going to just copy paste the dataset into my dataset directory. So I'll just paste that and now click on OK, and you should see the data set coming in any moment from now. It's a little bit heavy. I think it's about 5 gig. So now you have this is the data set. It's about 5.34 gig. So right now it's in read-only mode because of the size. Okay, that's fine. We can always read that by the time we are working with our code. Now, there's one other thing that I'll be creating. Inside my config file, I'm going to touch config.config.py, and inside our config, you will see this in here. All right, so the first thing we need is the config for our OpenAI key. I'm going to have config. I'm going to put our OpenAI key in here. But before we continue with the other keys, we want to test our architecture, okay? Whether it's in the right shape or not. So the next thing I want to do is I'm going to just do docker compose of the task that I'm going to build. Now that the images are ready, let's test them out to see if they are actually working or not. So we're going to open all the ports, and inside the 1990, I'm going to click on that so we can see how it looks like on the UI to verify whether the instance is ready to accept connection. I'm going to just switch this off. And you can see we have one worker with 2 cores and a 1 gig memory that we can use. So right now our instance is running and it's ready to accept connection. The next thing we want to do is have our WebSockets running on our system so we can start streaming data from this data review data set and extracting data in chunks from there. So let's continue. So I'm going to go back into my jobs and I'm going to create a new Python file and I'm going to call it streaming socket.py. Now inside my streaming socket.py, I'm going to be importing import JSON because I want to serialize the data. I'm going to be importing socket. I'm going to be importing time. All right. Now these are the basic stuff that I'm going to be importing. So the next thing that I want to do is have a function. I'm going to call the function send data over socket. All right. I'm going to be passing the dataset path, which is a file path. Then the host is going to be 127, my local host, .1. I'm going to have the port that I want to be using as 999, and I'm going to have a chunk size, which is the number of records that I want to pull. Each time we want to pull record from there, I'm going to say 2 for now. Then let's create a socket. To create a socket, I'm going to have s is equals to socket.socket, and I'm going to pass in the parameter for the socket. I'm going to be using socket.af.inet and the af.inet and the socket.sockstring. So that's the parameters that I'll be passing into my socket. Okay. Then I'm going to bind that on a particular host. No, not Bing. Is bind on a particular host and port, which is port. So I'm going to put them inside. Now, once that is done, the next thing is just s.listen. I'm going to listen. Then I'm going to print listening for connections on the host, which is the host, and the port is listening for connection. Okay, good. Connection, the address, and I'm going to have the accept. So whoever is connecting to this username, to this host and port, I'm going to accept connection from there. And I'm going to print connection from a particular address, which is the address that just came in. All right. So now this is showing that I have a host with a connection, and I'm now accepting connection from this particular person, a consumer that just connected to this instance. Okay, so right now we have a client and a server that I can send data to. Okay, so I'm going to continue. So after accepting connection from the client, I'm going to try and open the file path and then start sending data into that. So I'm going to have with open, I'm going to pass in the file path. I'm going to read as my open mode. And I'm going to call this as my file. Then, if there were some files that have been read before, if there are some files that have been read, that have been sent over, maybe they are inside the chunk. Let's say we have 100 records, right? In our case, we have about 7 million records. And out of these 7 million, a few has been sent over. We want to keep track of the indexes of those ones that have been sent, so we don't send them again. So if we are currently at, let's say, the chunk 5, we continue from chunk 6 in case it fails or something like that. So we want to continue. Okay, so I'm going to skip the lines that lines that were already sent. Okay, I'm going to skip them. by going into that in my range of, let's say, the last sent index. Okay, I'm going to just next the file. Okay, and I need to get my last sent index above my, I'm going to set that to 0. And so this is going to skip all the ones that have been read, that have been sent over before. Now the ones that have not been sent over, I'm going to have them inside the records file. I'm going to read the file line by line. I'm going to read them, and I'm going to be appending each records in the file. I'm going to be appending json.loads. I'm going to be loading the line. And once that is done, so if there is a line that has a record, and if that is equals to the chunk size, then I'm going to, let's say, print the chunk so I can keep track of what has been sent so far. I'm going to have pd.dataframe. I'm going to print the records that have been sent. So let's import pandas to do that. Okay. Now, for each of the records that I now have, I want to send them over. So I'm going to say for record in chunk.to dictionary, I'm going to be orienting them as records. I'm going to serialize them, serialize data. I'm going to do json.doms, the record, and I'm going to encode them in a UTF-8 format. Then send them over to the client, serialized data plus B R N. So if you don't have this new line at the end of your serialized data, the socket is going to be waiting for this and is going to think maybe you are not ready to send the connection over yet. So it is important to have the new line at the end of the serialized record that you want to send across. So the server knows that, okay, I'm ready to send this over to the client. Okay. So right now we continue. Okay. Then I'm going to sleep for some seconds, let's say 5 seconds. Then I'm going to be increasing my last sent index by 1. Then at the end of the day, once that is done, I'm going to clear the records. So I reset it. Then at the end of the day, I just need to close my try catch, and I'm going to come back in here. Is it? Yeah. I'm going to have my except. So if there's a broken pipe error or there's a connection reset error, what do I want to do? I'm going to be printing, okay, our client has disconnected. Okay. Then at the end of the day, I'm going to have finally, once everything is fine, I'm going to close the connection, close, and I'm going to print connection closed. All right. So we didn't install pandas, so I'm going to do pip install pandas. All right. Then let's populate requirement.txt. I'm going to have pip freeze requirements.txt so you can update the requirement.txt with pandas. Now let's take this for a spin and see if we are able to get the records across or even create our socket on the system. So let's take it for a spin. I'm going to just say Python, and I'm going to call the jobs. I'm going to say streaming socket.py, and Yeah, it's not working. So we need to call that in the main. So if the name is equals to main, we want to send over data over the socket by calling the, I'm going to just copy the path reference, and I'll just copy the name. I'm going to go into our data set. I'm going to put that there. And if I run this again, now we are listening for connection. We're in business. So we have our host and the port that we're listening for connection on. So let's test this out without the connection. Okay, I'm going to just stop this for now. And then over here, where I'm establishing connection, I'm going to just comment this out for now. I just want to see if the records are in the right shape or not. So I have my chunk in here. I'm just going to comment this. I'll comment those two so I can see if the data is in the right shape or not. So let's see. It says no such directory, datasets. I'm currently in the jobs directory, so I need to go one step up. I'm going to run this again. And it says connection is not defined. I'll just no such file or directory. Okay, so why is that? I'm going to just remove this. And you can see the data being produced, and you can see the review ID and the date. So it looks like this is getting produced every second without wait. This is good. So we have our data that is being produced. We are reading the data in chunks of 2, and it's being sent out from our original data set. So this is a good sign that our code is working. So we just need to put in the work of having the data sent over the socket. So I'm going to uncomment these guys and uncomment this one, uncomment this also. So right now, each time we pull a chunk, we are going to be sending it over the socket. That's part one. Now the second part is where we are going to be having our Spark stream listening for connection, serving as a consumer to consume data from over the socket. So I'm going to just come into my jobs folder and create a new file. I'll call it spark streaming.py. I'm going to be importing PySpark, and then from PySpark.sql, I'm going to be importing Spark session, and I'm going to be creating a Spark session that I can listen for. So I'm going to have if the name is equals to main, I'm going to have my Spark connection. It's going to be Spark session dot builder dot app name, and I'm going to have the app name, let's say socket stream consumer. Okay, I don't need this. I just need to get or create, and this is going to create a connection for me. So I'm going to pass this into a function. I'll call this let's say start streaming. I'm going to have my Spark, and this is going to be start streaming by passing the Spark connection into that. And I'm going to just say okay. Inside my Spark streaming, what I want to have is to read the data from the socket. So I'm going to have stream data frame is going to be reading data from the sockets over the read stream, and I'm going to be getting the format of socket, passing an option, if I can only type option, I'm going to pass in host. The host is going to be localhost or 127.0.0.1, and as well as the ports. The port also, I'm going to have my option of a port. It's going to be 999. Okay. Then once that is done, I'm going to load that. I'm going to just dot load. Again, this bracket is not necessary if everything is in the same line, but if you don't have this bracket in here, you are going to need to have a new line as a backslash so it can signify that it's a continuation. Just thought to chip that in. So it's just for me to have something clean. That's why I'm doing this. Okay. Now, once this is done, the next thing that I want to do is I want to have my query, and I'm going to say my query is streamdf.write stream. I'm going to be writing the stream with the output mode of append in the format of console, and I'm going to start. So maybe query.await termination. So again, let's double check this. I create a session, then I'm reading the stream from there. So let's create our session again. Our streaming session is here, and I'm going to run this. And let's see if we're able to read the data from the stream. And in the first batch, I have 0. So do we have anything being streamed out? It says my dump is missing a positional argument. I think it should be dumps. I just need to add an S to this, which was what was missing. And I'm going to rerun this again. Then I need to restart this session here. And we just wait for it to start. And it's coming up again. Let's see if our WebSocket is listening for connections. It is. Lovely. So right now, we're waiting. Okay, so the first batch, oh, lovely. And you can see them coming in. So I have my first batch, the second batch, the third batch, and they are coming every 5 seconds. That's lovely. The fourth one. Now, the next thing we need to do, once we have this means that our Spark is able to consume data from our real-time socket that is producing data every single second, every 5 seconds, not single second, every 5 seconds. So we need to make sure that we capture each record that is being produced from our socket. So I'm going to increase the number of the chunk size. From here, I'm going to increase it to, let's say, 5, for instance. And let's see if the value changes or not. So I'm going to stop this. I'm going to just stop this. Okay. And I'm going to rerun this. I'm going to just stop this. Okay. And if you notice one thing is actually missing at this point. If we disconnect from our WebSocket, it just hangs. It couldn't send anymore. And what that means is once it hangs, and if the socket reconnects, it's not going to pick it up. So we need to fix that. So let's quickly fix that before we continue. So in my streaming socket, I'm going to come back in here and handle that reconnection. Okay. So I'm going to have in my retry here, I'm going to have something added to this. So at the beginning here, once I have my connection, so what I'm going to do is here, I'm going to close my connection. This is done. And I want to make sure that anytime my connection, yeah, okay. So right now, our socket connection is done. I just need to double check that to be sure that each time we reconnect, we are able to continue sending from where we stopped. So I'm going to reconnect this, and intentionally I'm going to stop it. I'm going to we're going to see whether we are able to continue from where it stopped or not, because we need to have a system that is resilient and highly available, isn't it? Once it goes down, we have to reconnect, okay, and pick it up again. Okay, so let's go back into our socket. So this is sending. But interestingly, if you notice this, in our streaming, we are only seeing one record each time it reads. We are not seeing everything. So we need to fix that. That's the part one. The part two is once we disconnect and we try, and you can see that this guy is no longer sending. And if you try to reconnect, is it continuing from where it stopped? And you can see right now it says client disconnected and client connection closed. So we need to fix this this part. So even though it cancels, we want to wait. Okay, we want to wait for the connection to come in. And once the connection comes in, we want to pick it up and reconnect again to continue from where it stopped. That is the main goal. All right, I'm going to just minimize this. And so instead of just try here, I'm going to have a while loop here. I'm going to say while true. I'm going to move this up just to the front. And under my while here, I'm going to move this connection here. I'm going to move these two here. And so I can have something like this. And outside just my try catch, once that is done, what this means is once it cancels and it reconnects, there's a disconnection here, and it closes the connection, it's going to pick it up again and wait for a new connection. Makes sense? I hope so. So let's test this out to see if it is working as expected. So it's listening for connection. If we run this, now we are not submitting anything to any cluster, right? But we are just running. Okay, so we are waiting. So the first batch is done, second batch, and you can see it's sending data and this is receiving, but it's receiving just one record. We're going to fix that shortly. I'm going to just stop this. And you can see this guy is stopped. It stopped. I'm going to send it. I'm going to reconnect to that again. Let's see if we are able to reconnect. It says client disconnected, connection closed, but it didn't end our connection. We are still having a connection, and once we are reconnected, it continues sending. You can see that we are sending new records again. Lovely. So what this means is we've handled the reconnection strategy once we have a disconnection in our network. Okay, now let's stop this and fix our Spark so we can have real-time streaming in the batches that are produced. I'm going to just leave it like this and we continue. Okay, in our Spark streaming, so let's fix this and make it more robust. So in our Spark streaming, I have what's this called? Start streaming. Good. So I need to just move things around here, and okay. So ultimately what we want to do is produce to a Kafka cluster. Okay. But before we go into the cluster, we just want to fix this so we can have the right data being produced. So I'm going to have my stream df, which is fine. I'm going to just have a try catch in here. Okay, I'm going to move this just one step, and I'm going to have except and exception as E, I'm going to just print E for now. We're going to adjust this in just in a second. So the next thing we want to do is we want to have a schema, which is going to be a struct type. And it's going to be, what am I doing? Spark, yeah. It's going to be an array of a struct field of what we are going to be consuming and receiving from the socket, as well as producing to our Kafka broker, Kafka cluster or broker, anyone. So I'm going to just pick this in, and our struct field, I'm going to pick this in to import that, and then we are going to import string type from SQL types, and I'm going to just duplicate this a couple of times, comma, comma, comma. Okay, so we have the review ID, we have the user ID, the business ID, we have the stars, which is not a string, is a float type. I'm going to just replicate that a couple of times, and then we have stars, we have dates, and we are going to make this a string type. And lastly, we are going to have text. I'm just going to import this, import the floating type and add a comma to that. Lovely. Now, once this is done, we now want to read the data from the stream. Right now, what we are doing is we are printing out the data straight into the console, but this is just doing an output mode of append. So we are going to still use this, but before that, we need to transform the stream. So we are going to have a stream data frame, which is what we have in here, that is reading data from the socket. We are going to have another value overwriting that, and I'm going to have a stream df. I'm going to be selecting from JSON, I'm going to have a column of value. I'm going to explain this, how we come about that. And we're going to be putting this inside a schema, and then we are going to alias this as data to eventually select data from there, to say select data dot asterisk. Okay, let's just import this and we can quickly, I'm going to just minimize this and we can quickly explain what this is doing. All right, column. Now in the terminal, before I continue, in the terminal in here, when the data comes in into my Spark, you can see we have two columns, just a single column, not really two columns. We have a value of column, right? So what this means is everything that we are producing is going into the value column. So even though this is a JSON, but it's inside a single column. So we want to extract this data from here and convert it to JSON. So we are converting this JSON to this particular struct type schema, and we are aliasing that. So to say we are selecting everything inside that column value. Okay, so once we convert that JSON into this JSON in this column, once we convert it to a JSON, we are going to be selecting every record in that column. Okay, so the next thing we want to do is we want to write that to our output. And how do we do that? I'm going to have stream df just below here, the one that I commented out. I'm just going to minimize this. I'm going to have my stream df dot write stream. I'm going to be appending that from here, and I'm going to have options of truncate equals to false, and I'm going to await termination. All right, so select everything from there and then await the record. So I'm going to reduce the the production size, I'm going to reduce the production size to one record. Maybe 2. I'll just put 2 here. Okay, and in my stream sockets, that's my streaming socket. Is there any error message? Yeah, I just mistakenly deleted that. Okay, in my Spark stream, I come in here and I have everything rightly presented. So I just need to restart my. So it's waiting for a new connection. I'm going to stop that and I'm going to restart the terminal. So it's waiting for new connections and I'm going to rerun this. And you can see that we have the records that are coming in batches. So even if we increase the batch, we are still going to have the right records. Okay. So because what you see right here, you can see we have 2 records at this point. And even though we don't have a text field, I don't know why, we need to fix that part, but we should have a text field, which is part of the JSON. So let's see if I'm missing something. This is inside the text field. Good. So let's fix that. And in my Spark streaming, I have, I'm just coming here. So it's not a float type, it's a string type. Okay, so I need to stop this and I need to fix that. Most of you probably saw that. I mistaken when I was duplicating, I forgot to replace that string. And that is why you are not seeing value inside that text. But because we've handled the reconnection, so we don't have to restart our initial broadcast that we're doing from the socket. We just need to replace that and we'll be fine. And the first batch is done and you can see the data sitting pretty nicely. Now, at this point, we have our data being produced from our data set using the socket stream. Now we want to move into the Kafka section and we are producing data into our Kafka cluster. So bear with us and let's go into the Kafka Confluent Cloud and create a free Kafka cluster that we're going to be using for this session. Okay. So now we have our records that are produced and sitting pretty nicely. So I'm going to just stop this for now. There's no need to continue. I'm going to cancel this. So we have our records. Okay. So now let's move over to the Confluent Cloud. So on my Confluent Cloud, I'm going to just need to log into I'm going to have confluent.cloud.login. And this is going to log into my Confluent Cloud. So I'm just going to log in. You might not see the username and password. I'll just, and I can access my dashboard. Now, if this is the first time you are creating a Confluent account and you don't have a Confluent account, what you need to do is go to confluentcloud.com, confluent.cloud, and register an account. It's free and you have a $400 free credit. So with the $400 free credit, so far you don't misuse it. It's going to take you some time before you finish it out. I still have about 385, just like you. I created an account a couple of days ago, and I was just playing around with this Kafka cluster. So you can do the same and you still have your Kafka clusters. So what we are going to do right now is we're going to switch over to the Confluent Cloud and create a Kafka cluster that we're going to be using. So I'm going to start by switching over to the environment. So I have an environment currently running, but I'm going to create a new cloud environment. Okay. So I'm going to say add a cloud environment. So if this is your first time, you might need to just switch over directly to creating a new environment. But because I already have one, I wanted to show you how to create a new environment. Okay. So let's switch over and have, let's say our real-time, let's say reviews environment. So I'm going to create one. Now in this environment, it's going to ask me whether I'm using essentials or advanced. Thank you. I'll be going for the free. And I'm going to be selecting Google Cloud. You can choose AWS if you want, but I'll be using Google Cloud as my own provider. Doesn't matter what you choose. So let's select Europe, and I'm going to be selecting which one? Upgrade required, upgrade required. I'll just select Iowa to use the free one and enable. Okay. So right now I have the reviews environment. So the next thing that we want to do is create a cluster inside this environment. All right. Because inside this environment, you can have a Kafka cluster, you can have a Flink cluster, network management, schema registry, and other stuff, right? But we want to be particular about our Kafka cluster. So I'm going to switch over and select our own cluster. Okay. So I'm going to be creating a new cluster, and I'll just select the basic, which is the recommended version. I'll select that, and I'm going to be using a single zone, of course. In Las Vegas, I'll just select that. It doesn't really matter which one we choose. Thank you very much. Don't charge me. It's optional anyway, so thank you. I'll skip that. And in my cluster, I'm going to have review cluster, right? And this is the configuration and the cost per hour, really cheap. All right, I'm going to be launching my cluster. So it takes about a few seconds, maybe 10 to 15 seconds to finalize the creation of the clusters. And once that is done, we're going to just move on and continue from there. So right now we have a cluster, and inside our cluster we have API keys, networking, cluster, and the rest, right? So let's quickly talk through each of them. The networking is where you have your IP addresses into your environment. Don't worry, by the time I'm done with this environment, I'm going to delete this. So these are the IPs that are used by Confluent Cloud cluster as the source IP when you want to establish outbound connection to public IPs, but it's fine. These are the egress, but the ingress, you see them in here. We are not particular about that. Let's proceed to our API key. So we need to create our first key, right? And this API key is what will allow us to have access to our cluster that we are going to be creating. So I'm going to select the global access because I'm not for production ready right now. So I'll just select that and have my key. I'll just go in here, and inside my config file, I'm going to have Kafka. What am I doing? I'll just have Kafka, and I'm going to have so it's the API key, and I'm going to call it sasl.username because that's the username that we're going to be using as my API key anyways. I'm going to replicate this and change this to password, and just copy this as my password. Okay. Now, once that is done, I need my Bootstrap server, which is the endpoints that I'll be connecting to, which is the bootstrap.servers. I'm going to have my server URL in here. Then I'm going to have the protocol, which is the security.protocol, isn't it? And it's going to be SASL underscore SSL because I'm using HTTPS anyways. I'm going to have sasl.mechanisms, and this is going to be plain. Then if you like, you can add a timeout, but I'm going to just have it here, session.timeout.ms. I'm going to put that to 50,000. Good. So now let's replace the server URL. So switching back to Confluent Cloud, we go into our cluster settings, and you can see your Bootstrap server in here. I'm going to just copy this and switch over. And in my Bootstrap server, I'm going to just paste that in here. And this is my Bootstrap server and the ports. Lovely. So right now, this is our configuration for our Kafka. But I know for sure we are going to need a schema registry because we want to make it a little bit more robust. So you can easily, by the time our schema is evolving, we can easily track the changes and evolve with it also. So let's switch over to that. So in my schema registry, I'm going to need a URL, which is going to be a JSON, and I'm going to have my authentication information, which is the basic.auth.user.info. So I'm going to come back in here, and I'm going to go into my client. I'm going to go into the client and select the Python And this is going to ask me to create a cluster API key, which I already did. Okay. I think I'm going to use this key instead of this other one. I'm going to just copy this and I'll paste this in here because that's my client anyways. And I don't need to download and continue. Maybe I'll just do that. Download. Okay. Then in the schema registry, I'm going to create a schema API registry, schema registry API key, and I'm going to copy that. And inside my URL, my authentication in here, I'm going to have the username, which is usually like this, username and the password. If you are familiar with basic authentication with API, this is how you usually do it. So everything is converted to base 64 before connection, but that's the username and the password. Now let's get our schema registry URL. Our schema registry URL, I'll just download and continue. Okay, so this is our schema registry URL. I'll just copy it from here and I'll just copy and I'll paste it inside our URL at this point. And you have Bootstrap servers, everything in here. Is this the BAD? Yeah, good. All right. And the PKC lizard or something like that. Good. So our keys are fine now. Now let's proceed and do a connection to our Kafka cluster. So let's modify. We're going to be modifying our Spark stream so we can now connect with these credentials that we have in our config. We use these credentials to connect to our Kafka and the schema registry on the cloud. So in here, in our Spark stream, I'm going to just import the package. I'm going to be importing the config, which is from config.config. So I'm going to be importing config, right? Then in here, so instead of just writing to the terminal, I'm going to switch over from here and I'm going to write, instead of to the terminal, I'm going to be writing into Kafka. And how do we do that? I'm going to have my, so instead of writing to the terminal, I'm going to write into Kafka. So I'm going to have a Kafka data frame, which is going to be selecting data from our stream DF, and we are going to have a select expression. So I'm going to be casting select expression. I'm going to cast review ID as my key. Okay. I'm going to cast that as a string. I'll just minimize this. I'm casting that as string and this as a key. Then the rest of the value, I'm going to be converting them to JSON and I'm going to have a struct, select everything from there. And this is going to be selecting everything as value. Good. All right. So right now I have a Kafka data frame in my Spark. So what I want to do now is write this stream to the Kafka cluster. So I'm going to have my query. I'm going to call the Kafka data frame. I'm going to do a write stream. I'm going to say the format of that write stream is going to be writing into Kafka. And then I'm going to be passing a couple of options into this. So I'm going to be passing the kafka.bootstrap.servers. Okay, I'm going to be passing the config. Yeah, I'll just move this here and I'll close this. So I'm going to have my config. I'm going to be extracting Kafka from there. And I'm going to be extracting the bootstrap is it dot servers, is it? Let's go into our config. bootstrap.servers. Good. So bootstrap.servers. Then I'm going to be passing another option. I'm going to say Kafka.security.protocol. I'm going to be passing config Kafka, then security.protocol. Then I'm going to have another option, Kafka.sasl.mechanism. I'm going to have config Kafka, and I'm going to have sasl.mechanism. Then I'm going to have options. Yeah, I'm going to have option of the username and password that will be used to connect to the Confluent cloud. So I'm going to be using the username and password that we have inside our config file. So which is configured by using the kafka.sasl.jaas.config. Then I'm going to be passing the class that will be using for the login. So which is coming from the org.apache.kafka.common.security, the plain and the plain login module. So I'm going to be required the username and password, which is going to be required. So I'm going to put that inside username, and I'm going to have the password also passed into that. Password equals to this. And at the end of the day, I'll put a comma in there so I can format the data with the username. It's going to be coming from config, which is the Kafka. And we're going to be passing sasl.username. And for the password, we're going to be passing config Kafka sasl.password. All right. So finally, once these are done, the next thing we want to do is set a checkpoint. So we're going to have a checkpoint location, checkpoint location, and that is going to be /tmp/checkpoint. You can choose any directory you want. It doesn't really matter. Then finally, we're going to pass in a topic, which is where our data is going to be sitting in on the cloud. Topic. We don't have a topic right now, but we need to create one. So we're going to start and await query termination. And eventually, I'll just have exception encountered. So it's going to be E, and then we are going to be retrying in maybe 10 seconds or so. So we just sleep. We sleep for maybe 10 seconds, and then we try again. Just import this. I'll just import the name from time.sleep. Now, one final thing that we need to do, this is supposed to be equal to, and eventually we need to set our topic, which is going to be the value of the topic variable. So we're going to have, let's say we have customers, maybe product review, customers product review. Usually we have maybe customer reviews is fine. Oh, customers review. Yeah, I think that works. I'll just put that in a string so I can use it also in here. Good. Now, at this point, we have our Kafka set up. Right now, what we are doing basically is a one-to-one mapping from the customer review down to Kafka. But eventually, we want to do a sentiment analysis on this review using the large language model that is provided by ChatGPT, OpenAI. So we're going to use that to check the to perform the sentiment analysis on the review text, which is the comments of the customer. And once we find that to either be positive, negative, or neutral, we are going to add that to our data that is coming from the stream and pass down into Kafka. So let's just proceed and see how that goes. So I'm going to have the data in here. So let's create our first schema. So I'm going to just come into this data. I'll just copy, and inside our schema in here, I'm going to make a directory. I'll call it schema. Maybe it should be schema and schemas, because we could have potentially multiple schemas. So I'm going to just create a new schema inside that, and I'll call this reviews.schema.avsc. And that's Avro schema. I'll just paste into that. And we just need to adjust this to cater for that. And what we have right now is this initial review. So without the feedback, I'm going to just remove this. And this is the structure. So we just need to fix this particular name in here. So the name we are choosing for our topic is the customer's review underscore schema. So I'm going to add underscore schema to that. I'm going to copy that. So we can go back into our Confluent cloud in here and go into the topics. So I'm going to create a new topic and say create topic. I'll call this customers review. Is that what we have in our topic? Customers underscore review. Good. So I'm going to be using 6 partitions. You can read up what partitions is, but basically, to just summarize it, is more like things that are related to each other. So if you have maybe a key that are related, they will be grouped into a particular partition, the other ones into other partitions. That's the basic summary, but you can read up on the documentation on that. You can also see the number of partition, which is the default. So I'm going to create with default customers review, and it's going to ask me to create a schema for the value. So you can create a schema for the keys and for the value. So I'm going to create for the value and get started. Okay. So I'm going to be selecting the Avro schema. You can use the JSON schema, and you can see the sample of how it's going to look like if you use the JSON schema. And if you're using Avro, it looks like this. If you're using protocol buffer, it's going to look like this. All right. So I'm going to be using Avro. So I'll just replace that with what I've copied from my AVSC in here. This is the where is it? No, is this supposed to be Python? I'm going to rename. It's supposed to be AVSC, and that's supposed to be the extension, not .py. Okay. So that's my schema in here. So I'm going to be having review user ID and the rest of this data. I'm going to validate this, and it says there's an error, which is the comma. I'll just validate that, and you can see the validation passed. So I'm going to create. Now, if I look into the overview, and I don't have anything produced or consumed right now in the message, you will see that inside my topic, I have a schema that I can use at this point. Lovely. So now let's take this for a spin and see if our code is actually working, connecting to the cloud and producing data into our topic. So let's run this. All right. So I'm going to go back into my Spark streaming, save that into my socket streaming, and run again. Is this running? So it stopped. I think I stopped it. All right. So I'm going to just start my socket streaming again. And now it's listening for connections. So in my Spark streaming, I just need to send this over. Yeah. Okay. No modules name config. I think it's high time we start using our cluster, because right now we need to use the cluster to submit this job. Okay, so let's go over in here, and we have our cluster set up, and this is our master running. If I refresh this, it's still up and running. Good. So all I just need to do is exec and submit the job into that. So docker exec, So I'm going to be submitting data. I'm going to be executing interactive terminal into my Spark name, which is the cluster name, my container name, this guy. You can see the master. So I have the Spark master, and I'm going to be submitting to the Spark master. I'm using the package of SQL Kafka of 3.5, and I'm going to be submitting the job of Spark streaming. But before I continue, inside here, I'm going to stop this. And because I'm now going to be running the Spark on the Docker container, it makes sense to run the socket on the container too. So I'm going to just do docker exec interactive terminal. I'm going to go into the Spark master, and I'm going to use bin bash so I can bash into the container. So so right now I just need to check if I have the jobs inside the jobs directory, and if I list the jobs, I can see I have my Spark streaming and I have my streaming sockets. So I just need to do is Python jobs and streaming socket.py. It says no module name pandas. I think we need to go out of here and rebuild our Docker Compose, because it was after we finished building the initial one that we installed the new pandas. So we need to fix that. And I already did a pip freeze, if you can recall. I already did a pip freeze into our pandas and into our requirement.txt with the pandas package. So all I just need to do is rebuild the container, and we should be good. All right, so the Spark master and the worker are done recreating. So we just need to go in there and run our code. So I'm going to just do a docker exec into the bin bash of master. I can do the same on the worker. It doesn't really matter because they have the same image anyway. It's just maybe the master or the worker class that's different. So I'm just doing docker, not docker. I'm going to be doing Python jobs, and I'm going to be doing streaming sockets. Lovely. So this is waiting for connections on one localhost 9999. Lovely. So the next thing we want to do is submit a job to this Spark master. So I'm going to be using the Spark worker for this. Spark worker. And I'm going to send this across. So there's an error called bootstrap.servers. So I'm going to stop this. So the bootstrap servers typing is wrong. It's not bootstrap, it's bootstrap. So I'm going to just correct that. So let's fix the bootstrap error. I'm going to come into the Kafka here and then fix it here. That's the bootstrap. That's the error. And I need to fix the reconnection. So because right now, once it tries and fails, it just sleeps for 10 seconds and ends there. So we want to fix that. So while true, we want to keep running even if it fails, and then restarts again. Good. So that's the part one. The part two is the host. We are no longer running on local host. We are now running on the container. So I'm going to change this to 000. And in my streaming socket, I'm going to change from 127, which is my local host, to Spark master. And I think we should be able to undo any error arising from this. And I'm going to just go ahead and run this. We can ignore this. It's not an error per se. So I'm going to rerun my terminal. This is going to synchronize into the Docker containers. I'm going to go in there and I'm going to have docker exec it spark master. Then I'm going to go into the bin bash So I can do a Python jobs and Spark streaming. Not Spark streaming, it's Spark streaming socket. So I can start my socket to listen for connections. So it's listening for Spark master, so 999, good. Then on the other hand, I'm going to have Docker exec. I'm going to be submitting the job to the Spark master using Spark submit with the Spark master URL, this, and then the package. And I'm going to be submitting the jobs of Spark streaming job. So let's see if this actually make any difference. So right now it's producing, and you can see it's producing right now. It just produced another one, and it's producing. So good. So now let's go into our Confluent Cloud and go into our customers review topic. I'm going to go in here and we're going to check our messages to see if the data is coming in or not. A few seconds and we should be able to see. And lovely, you can see the data coming in. And this is nice. So each of the data that is produced is coming into our Kafka queue and into our Kafka topic. And you can see them. If I click on this, they're coming in. Lovely. So the next thing we want to do right now is to add the sentiment analysis from the OpenAI Large Language Model, aka ChatGPT. So let's do that. So I'm going to go into my OpenAI. So I'm going to have platform.openai. I'm going to go into the API section, API keys section. Then I'm going to create an API key from there. I'm going to call it secret key. I'm going to create a new secret key and I'm going to call it real-time streaming. Okay, and I'm going to create secret key so I can copy that. I'll copy this and done. Then in here, I'm just going to stop the streaming because it's just going to keep producing data into the Kafka. So I'm going to go back into my config and in my OpenAI key, I'm going to paste that key in there. All right. Then I'm going to go back. So I'm going to have a function. I'm going to call the function sentiment analysis. So I'm going to say def sentiment analysis of the comment. And this is going to return a string for me. And based on that, I'm going to say if there is a comment, I'm going to say import OpenAI. Yeah, let's import OpenAI. We already installed the packages and the package anyway, so let's import it. And then we say if there is a comment, we call OpenAI, and then we set the API key to config OpenAI, and then we pass in the API key. Now, as part of the arguments, we are going to have a response, so which is going to be OpenAI chat completion. Then I'm going to create a chat completion. So I'm going to be using the model GPT 3.5 Turbo. All right. So I'm going to be using the messages argument, which is going to take in an array. And the first one is going to be the row of. So I'm going to say this is the system and then the content. This is where the prompt is going to be sitting in. So I call it this one. So I'm going to be using the three quotes. I'm going to say you are a machine learning model to set the construct with a task of classifying comments into positive, maybe I should just reduce it a little bit into positive, negative, why is it not good? Okay, negative, and then neutral. Then you are to respond with one word from the option specified above. Do not add anything else. Full stop. Here is the comment. Then I pass in the comment. Then I format that to have my comment equals to comment. So with this, my battery is getting low. So with this, I'm going to send that into ChatGPT, and I'm expecting a response from the completion. So I'm going to just minimize this so I can have return completion dot choices. I'm going to be choosing the first choice and then the message from there to extract the contents. Okay, so, and we said if there is a comment, do this, otherwise return maybe empty. Okay, so let me talk you through what this is doing. We are setting a construct for the machine learning model to say you are a machine learning model and your job is to get an input and provide a single word as the final output. So what that is going to do in the background is going to set a stage for the data that we're bringing in and the outputs that we're expecting from that model. So let's see if this is actually working or not. So I'm going to go back in here and implement the sentiment analysis as part of my streaming, my Spark streaming. So I'm going to have, before I go into selection at this point, once I have my data dot asterisk and I'm selecting everything from there, what I want to do next is I'm going to create a UDF. So I'm going to have sentiment analysis. I'm going to underscore UDF, and I'm going to be calling the function of UDF to say, call the sentiment analysis. I'm passing a string type to it, string type. And what this is going to do for me is I'm going to have another stream df that is going to be piping the data that is coming from the stream into the sentiment analysis column. Okay, so let's fix that. And we have stream df. I'm going to have a with column. I'm going to be passing a feedback as the column that I'm creating. And when the column of text is not null, I'm going to perform sentiment analysis UDF with a column of text. Okay, otherwise I'm going to be passing none to it. So I'm just going to import this package from PySpark, and I'm going to import this also from the functions. So what this is doing is when you get in here, create a UDF and then create a column with a column of name of feedback, right? And then when the column is not null, create pass the column value into this UDF, and then if the column is null, then you pass none to it, and we get an empty response into the feedback. That's what we're doing basically, and this is how you eventually link the OpenAI stream into your Spark stream. OpenAI sentiment analysis into your Spark stream. So let's see if this is actually working. Let's take it for a spin, shall we? And yeah, I'm going to just save this, and I'm going to go back to my terminal, and I'm going to rerun the Spark submission job. Okay, so it's producing, but there's an error in here. It says out of bounds stream failed. So there are two things that comes to mind. If you can recall, I was talking about the schema evolution the other time, and because we've now added a new schema, there's an error when we are producing data to the topic. So let's fix that error on the schema. So I'm going to go back into my schema on the Confluent Cloud. And in the topic, I'm going to edit the schema. I'm going to go into the schema section and evolve that schema. So evolve schema. And in here, I have a text as the last record. I'm going to just copy that and paste. And I'm going to be passing feedback as the additional column. So I'm going to validate. It says schema being registered is incompatible with earlier schema for the subject. So there's an error in here. So what I'm going to do is I'm going to drop this schema and I'm going to recreate a new one. So let's go into the schema registry. Okay, I'm going to have schema registry, and inside my schema registry, I'm going to just delete this. Yeah, I think I already tried to evolve this, but it wasn't working. Did it? Yeah. So I'm going to just cancel this and just remove this schema. And then I'm going to add a new schema. Okay. And I'll call the name customers review schema. That will be the schema name. Validate and then create. And I'm going to produce data into that. So let's see if I'm able to produce new data into the topic. So it's producing. So let's see if we get the record on the topic. It says there's an error in here. I'm going to just stop this. And what's the error? It says out of range, replacement index 0 out of range. So let's see, there's an error with my formatting. I didn't pass in comment into that. You probably saw that, didn't you? And is there any error message? I'm going to run it again. I didn't see that. Okay, so we have the source, which is from here, and we have the destination being sent as the sync. So do we have any record? And lovely. And if we see, if you can check in here, we can see we have a record of feedback, which is negative. And is this negative? The good price and all that. It says Le Benedict can't even cut through arm or English moving. Tried on all 3 occasions. Hell bread don't even. Right. Interesting. So this is a negative feedback anyways. And we can see some other ones. This is also negative. And this is positive. It says stop by after Sunday morning walk in the park. Great food, great coffee, great summer service. Love the vibe in here. So it's a positive. So that means our OpenAI sentiment analysis is doing a good job, and we are having our records being published to the queue. To the topic. So this is lovely, and that means our prompt is working as expected and everything is working smoothly. So the next thing we want to do right now is have a connection between our Kafka, which is this is the last part of this series. We're going to have a connection between our Kafka and Elasticsearch. And how do we do that? So once the data is being produced to the Kafka queue, what we want to do is automatically index them on Elasticsearch. Simple as it is, but we're going to see how we are going to do that on the Kafka clusters. So I'm going to go back to my Kafka cluster. I'm going to leave it as production in production, and I'm going to go into the connectors. All right. And in the connectors, I'm going to have my connector plugins, and you can see the already configured plugins. So I'm going to select the sync and select the Elasticsearch service sync. So I'm going to be selecting customers review as my topic. Then I'm going to click on continue. So it's going to ask me to download the API key, which I'm going to generate and download. All right, so I'm going to copy this and download this somewhere. Okay, so this is my API credentials to connect to my Elasticsearch sync service. All right, so I'm going to I just downloaded that. I'm going to just click on continue, and I'm going to now configure my Elasticsearch. So right now, if you go into the Elasticsearch and Elasticsearch, that's cloud.elasticsearch.co. So if you don't have an account, this is a great way to create an account. But because I already did, so once you create an account, they are going to give you 15 days free trial. So the first thing you need to do is create a deployment. Because I'm using a free trial, trials are limited to one deployment at a time, so I can't create a new deployment. But the deployment is easy and straightforward. All you just need to do is select your deployment, select your cloud provider, and that's it. Once you do that, you will see the parameters that you're going to be passing into that. So all you just need to do is select your deployment region. I'm using the GCP in here, and I'm using the Iowa Central as my default instance. I'm going to have all of this created on the fly once you select the GCP. You don't need to provide your credit card, just sign up and you have access to that. Now going back to my deployment. So this is my deployment and I'm calling this streaming project. So right now, if you look at my, if I go into the Elastic Home, and I go into the Cloud Console. So I'm going to go click on my deployment, and in here I'm going to click on the Elasticsearch, and this is going to take me directly to my Elasticsearch home. So this is the home and this is how it looks like. So I'm not going to go through every functionality of the Elasticsearch. I'm just going to go directly into the indexing part. Okay. So we're going to scroll down and go into the search section where we have the search, and I'm going to have the content. I'm going to go into the content. So in the content, you see the list of indices you have. Right now, we don't have any index or indices on this instance. So I'm going to create a sync right now to Elasticsearch. Okay, how do we do that? I'm going to go into my deployment section, and I'm going to just wait for this to initialize. Maybe I'll just refresh. All right, so right now I'm going to come in here and click on the Elasticsearch aspect. I'm going to just copy the endpoints to the to clipboard. So copying the endpoints, I'm going to paste that into my connection URI. My user is Elastic, and the password is inside my security. I'm going to come to the reset password because I can't recall the last password. I'm just going to reset that and copy the password. I'm going to rotate this, so you don't even try to use this. It's not going to work. So I'm going to come back in here and paste my password into that. I'm going to continue. Okay. So I'm going to be selecting Avro as my schema value, the record value format. I'll select Avro for that. And in the advanced configuration, schema ignored is going to be true. So what I want to do is, once you ignore the schema, Elasticsearch is going to infer the schema by itself. So there is no need to straight type the schema. You can do that if you want, but I'm going to be skipping that to ignore the schema. So I just click on continue, and the sizing, I'm going to have one task and review and launch. Let's see everything if it is okay or not. I'm going to just call this reviews schema Elasticsearch connector. Maybe sync connector. All right. And the topic that is connected to is customers review. I'm just going to click on continue. So it takes a few seconds to provision, and I'm going to allow. So it takes a few seconds to provision the connector, and we're going to see if it is running or not. So I'm just going to, so the review schema ES-Sync connector is now running. I'm going to just click on this connector and let's see. So it's not processing any message as of this moment, and there's no message in the DL queue. So if there is a message that made it to Kafka, but the format is incorrect or the schema is wrong, those kind of messages are going to go into the dead letter queue, the DL queue section. That means the data is still on the queue, but it's not in the right format. So instead of just removing them from the queue or the topic, it's just going to put them in a dead letter queue, which you can use a streaming function or a streaming pipeline on the cluster to fix and correct whatever error is with them back into the original queue. But that's not the context of this video. So right now we don't have any message being processed by the sync. So let's see if we are able to process data directly with the connector, automatically with the connector. All right, so right now let's go into our connector and stop. So I'm going to stop this producer, and I'm going to restart it. So this is going to maybe stop, and I'm going to start it again also. So it's going to start from the beginning, and this is going to connect to it and start producing data again. So let's see if we are able to replicate data from our Kafka directly into Elasticsearch. So let's go into our topic. Our topic is this. So is it producing any message? Yeah, so it's producing and it's being consumed. All right. So let's see if our connector is working as expected. So the messages are going straight into the dead letter queue. Okay, so that means even though it's going into the dead letter queue, but we are still producing the data. So let's fix that. Okay, and it says, what's the error message in here? All right, let's see how the messages look like. So I'm going to go into the zeroth partitions and see. So these are the data that are coming in to the dead letter queue. Okay, and do we have any data that is produced? None. All right. So what I'm going to do right now is I'm going to go back into my topic and remove this topic so I can create a fresh one with the right schema. So I'm going to come into the configuration and delete this topic. Okay. I'll delete that and delete the DL key also. There is no point. So some data are coming into this and they're failing. All right, so I'm going to come back and create a new topic. I'm going to call the topic name customers review. Is that the name of the topic? Customers review. All right, and then create with default. Then set a schema. I'm going to come in here and set a schema for that. And my reviews of schema, I'll just copy this and paste that into this. I have customers review schema, and I'm going to validate, and I have a feedback that is missing, which is the feedback, and the type is a string. Okay, let's validate that. So it's passing and then create. All right, and in my Elasticsearch, so I'm going to see, I'm going to change the configuration format to JSON, and I'm going to save, apply, and we said ignore schema. Schema ignore is true. Okay, good. So now let's go back into the topic and produce data into that. I hope this is going to produce data into our Elasticsearch. Okay, I think it's producing now. And do we have any data in this topic? Okay, data is coming in. So let's check our connector. And in our connector, let's click on that. Do we have any message processed? Elasticsearch. I'm going to refresh this. And you can see data coming in. So we have customers review. Now inside our customers review, we have 16 document count, which is good. So right now, data is coming into our indices and into our in the UI. I'm just going to go back in here and go to our dev tools so we can run our queries against that. So I'm going to just write our queries, and I'm going to start with getting the customer's review, and I'm going to go into the search, and the query is going to be, I'm going to pass it. The query is going to be to match the fields that I want to match. Maybe I should just match all for now. So just match all, and I'm going to run that. Right now I have 27 records, which is the total value, and the max score of this is 1. And you can see the records in here as well as the feedback for each of them. Okay, and continually I can also have another query. I'll just copy this. I'll just say, let's say I want to see anyone that has amazing, right? I'm just going to say match phrase, and the text that the field that I'm going to be matching is the text field. Okay, and the phrase that I want to match is amazing. If I send this across, I'm going to see the number of records that has amazing. And you can see the first one. If you look at this, it's an amazing jewel. And this also, where is amazing? Where are you? Amazingly amazing. And the next one is amazing bikes. So lovely. So let's just do one last thing with a more complicated, not complicated, just more complex query. So what I want to do basically, I want to group the number of positives and negatives that are on the Elasticsearch that have been indexed by Elasticsearch, and see the count of the total group of these buckets for the positive, negative, and probably neutral sentiment analysis that have been done by our ChatGPT large language model. So let's quickly write that. So I'm going to write the query for that, which is the get. I'm going to say customer review, and I'm going to do underscore search. So I'm going to pass in the initial size, which is going to be 0. Then I'm going to do an aggregation. So the aggregation is a group by feedback. So the aggregation type is going to be terms. It's going to be on the field of feedback.keyword, and I'm going to perform the aggregation of AGGS. The name is going to be total count. Then I'm passing the value count into that for the field of feedback.keyword. Okay, hopefully this is right. Okay, I'm going to send this across. Oh, lovely. So what this means is I'm grouping by the buckets of the feedback. So it says the aggregation is going to be group by feedback as my root. So then we have the term, which is going to be the feedback.keyword. Then the aggregation in this case is the value count on this keyword feedback.keyword. Right now you see 5213 and you have 1. So if I run this again, you see 5813 and 1. So you can take it further from here by connecting different types of visualization endpoints. You can decide to have your application set up with any programming language you want, like maybe JavaScript or Python or any other language that you want, where you are going to be leveraging the powers of Elasticsearch to develop a beautiful UI and maybe a beautiful dashboard on the UI. Aside from that, you can also use something like OpenSet, Power BI, or even Tableau with their connectors to Elasticsearch to stream data in real time into these visualization dashboards. The possibilities are endless. So, but that is not going to stop there. So I want you to go further, write some more queries, try to perform different aggregations, and select maybe and try to derive some insights from this data. If you have not subscribed to the channel, I would like you to please click on like, share, and subscribe to the channel. And if you have any questions at all, or you have contributions and feedback, please do that in the comment section below. And until next time, I'll see you in the next video. Thank you.